Carnosic acid might not sound like something you'd want near your neurons. After all, it has acid in the name, but this plant-derived compound from rosemary and sage is quickly rising through the ranks of neuroprotective candidates. Long valued for its antioxidant properties, carnosic acid is now drawing attention not just as a food-based brain booster, but as a lead molecule in the race to develop next-generation therapies for cognitive decline and neurodegenerative diseases like Alzheimer's. And here's where things get really interesting. Scientists aren't just studying it in its natural form anymore. Stabilized, synthetic versions of carnosic acid are being engineered to enhance its potency, shelf life, and drug-like behavior, ushering it out of the spice cabinet and straight into the clinical pipeline. At the cellular level, carnosic acid operates with remarkable finesse. Unlike blunt force antioxidants that simply mop up free radicals, carnosic acid takes a more strategic route. It acts as a prodrug, remaining inactive until it encounters oxidative stress. When neurons are under siege from free radicals, which they often are in aging and Alzheimer's, carnosic acid activates and binds to KEAP1, a regulatory protein that normally keeps the body's internal defense system in check. Once KEAP1 is disabled, a transcription factor called Nrf2 is unleashed, triggering the production of a whole army of antioxidant and cytoprotective enzymes. This means carnosic acid doesn't just neutralize oxidative damage, it ramps up the brain's own ability to defend and repair itself. In effect, it's like installing a fire alarm that not only alerts you to danger but also activates the sprinkler system, calls the fire department, and rebuilds the walls while you sleep. This activation of the Nrf2 pathway is a huge deal in the context of neurodegeneration. Oxidative stress is a well-known contributor to beta-amyloid accumulation, tau phosphorylation, mitochondrial failure, and chronic inflammation, basically all the worst parts of Alzheimer's. By intervening upstream, carnosic acid has the potential to disrupt the disease process early, before it spirals out of control. Now, for all its promise, the natural form of carnosic acid isn't perfect. It degrades quickly when exposed to light, heat, or air, and its bioavailability, how well it gets absorbed and delivered to the brain, is less than ideal. That's why pharmaceutical researchers have begun developing stabilized and synthetic analogs that retain carnosic acid's core structure, but with chemical modifications to improve shelf life, absorption, and blood-brain barrier penetration. These next-gen versions are already showing promise in early lab and animal studies. Some are being designed to cross the blood-brain barrier more efficiently, others to stay active longer in the body. In several mouse models of Alzheimer's disease, stabilized carnosic acid analogs have reduced brain inflammation, preserved synaptic density, and improved performance on memory tasks. One team even reported decreased levels of insoluble beta-amyloid plaques and tau tangles, suggesting not just prevention, but possible disease modification. Even more exciting, these benefits often come without the side effects that plague conventional neurodegenerative drugs. Because carnosic acid activates natural, endogenous defense systems rather than interfering with neurotransmission or artificially blocking protein buildup, it may offer a gentler, more sustainable long-term approach to brain health. Think of it not as a hammer, but as a tuning fork, bringing the brain's own defenses back into harmony. There's still a long road ahead. Clinical trials in humans are sparse, and turning a botanical compound into a rigorously tested pharmaceutical requires years of testing for toxicity, efficacy, interactions, and manufacturing challenges. But the direction is clear. Carnosic acid isn't just an interesting nutrient anymore. It's a lead candidate in a new class of neuroprotective agents rooted in nature but refined by science. So yes, the future of brain health might be rosemary-scented, but with a synthetic twist. In a world where most Alzheimer's drugs target single pathways with limited success, carnosic acid offers something refreshingly different. A systems-level defender, stealth-activated by stress, and now being transformed from seasoning to serious science.